Okay, ELC128, worksheet 22. What is a one shot and how long is it on? How long is it on? So, if I go back to my my memory location, and I did the immediate. Okay. And there's my one shot on my output. What a one shot does is it turns the bits on for one scan. So if I look at the logic, when the moment X3 becomes true, Y7 output will be on. Whether it's immediate or not, I can take that off. Y7 will be on, but it will only be on for one scan. So the next time around, if X3 continues to be true, Y7 is not going to be fired. It will only be on for one cycle. Okay. We use one shots in as far as controlling our outputs. So let's okay that. Let's okay that. The other one you get is the edge contact. So put that there, do an edge contact. Okay. So you can get this on, this input on, when the bit turns on, when it goes from a false to a true, or you can get it on when it goes from an on to an off. So you've sort of got an edge contact that you can use on your memories. What I use, X3, so let's do X4. They have an arrow, so this will be on only when it changes for one, when it's going from a 0 to a 1, because the arrow is going up. So this will only allow this to be on for one shot. Okay. And so in this program, I've got my routines. Oh, I made my outputs one shot execute. So when C1 goes off, this will only happen one time. And this will only happen one time when I go to manual. So that's what one shots do for you. They only are on for one scan cycle. And when is the term rising or falling used with a one shot? Click calls that an edge contact, but it's an input one shot. So your inputs can be on for one cycle. Because if you go think about it, if you go from a 0 to a 1 and you maintain the 1, it's not changing. So that input, that edge contact, is only on when for the scan that it's changing. Now I want to go down. There we go. This is only on for the scan that is going from a 0 to a 1. And that's what click. Well, Alan Bradley has one shot inputs and outputs. Click has one shot on the outputs, and then it has this edge contact on the inputs. So that's a little bit of a difference. How can it be used in subroutines to keep unwanted outputs from being on? So what I'm doing in this subroutine here is when I switch between, oh, there it is. When I switch from automatic to manual, I am writing this. I think these are all zeros. So the minute this becomes true, I'm copying all zeros to my outputs. but I don't want it to copy all zeros to my outputs every time it comes through and scans it. So I made it a one shot. So when this becomes true, this happens once, and then this has to go false and come back to being true again before this happens again. And, oh, I'm writing this timer back to 0. I want that to happen once, not every scan when I'm in manual. So I'm writing the automatic timer back to 0. And so you get situations like that where I'm about to assign a program. So let's talk about the program. It's got a manual routine and an automatic routine, and that's sort of what I did on my program that I used in the video. So you've got that video out there. In my main ladder, you've got some kind of manual control of lights. And then automatic, you've got the lights doing something automatically that you don't have buttons on. Well, if I'm in manual and I've got lights on and I go to automatic and they're in different subroutines, I need to be able to turn the manual lights off so that automatic can now have control of them. And that's what I'm doing with these one shots here. So when I go to manual, I write all my outputs off and I reset my automatic timer. And then when I go back into automatic, I write all my outputs off, so then when I go to my automatic subroutine, it can write them on based on its logic. And when I go to manual, I write them off, and then my manual logic writes them right back on, because this only happens once. Okay, let's see here. So program it. Manual subroutine and automatic subroutine. In manual, you've got switches that control lights. You can use switches. You can use C bits and the data view to turn on and off the C's if you'd like. Use at least 3 lights, switch controlled. In automatic, the lights vary and sweep in some fashion. You have plenty of options. I think what I did is I had my lights cycle through all 6. No light should stay on when switched between subroutines. That's what I did in the program here. This is what prevents that. These little one-shot statements. So that's good to know. Write a program, prove it, and turn it in. 11, why is the use of subroutines helpful to the troubleshooter? If your manual's not working, what logic do you look in? You look in the manual logic. If your automatic's not working, where do you look? You look in the automatic subroutine. So subroutines help break down the program so you can generally narrow down where the problem is. Originally, PLCs where everything was in one ladder, and you're talking 200 or 300 rungs that everything had to go through. It's helpful to the PLC because if I'm not scanning the manual ladder, if I'm not going to the manual ladder, I'm not calling it. If C1 is on, then I'm not even going to manual. So any logic in there is not even scanned. And that's going to help my scan time be reduced. So I can have a pretty long program. Now, I could bring those subroutines back and put them here as a subset of C1. I can do that. But then I've got my automatic program and then my manual program and then all this stuff switching between them. And then everything would get scanned. Whereas when you use a subroutine, you can limit what gets scanned. That makes your cycle times faster. And if you make your cycle times faster, it's more likely that no buttons or no inputs will ever get missed. And all those are positives. All those are positives. So it's helpful to the PLC in terms of scan time. And so now what happens if motor forward and motor reverse were able to be energized simultaneously? You would create a dead short, phase to phase dead short in a three-phase system. Now the motor is downstream of your short, so it's not necessarily going to be hurt, but you will definitely test the overload protection of the circuit because you have just shorted out phase to phase, and that's bad. All right. 14, can you see the one-shot output true when viewing the condition status online with the program? So if I go in here to my condition status and I look for this to be true and it's a one-shot, I'll never see it. Not in Allen Bradley, not in Click, because it's only on for one scan time. So, 7 milliseconds, that's not enough for this computer to update. One shots are one of those things you just have to know that they work. You see the evidence after the fact that, oh yeah, that one shot had to have done its job or we wouldn't be where we want to be in a condition wise. If you didn't have a one-shot instruction with your PLC platform, how could you create one with standard logic? What if I had that? Okay. That's a good one to look up, actually. How do you create one in standard logic? Now, I will tell you, in Allen Bradley, you use a memory bit. I can probably do it here. Let's see what we can do. Okay, so I've got my random input coming in, and let's say it's X7. And I want this to be a one-shot. So what I'm going to do is I'm going to do C7 off. Okay. And then this output will be C7. Now, when X7 happens and C7's off, what's the condition here? These are both true. And then this comes on. And then this output of C7 is only on for one scan. It's only on for one scan. Yeah, that's right. Seems like there's two rungs, but it's been a while. So the C7 is only true for one scan. Then if X7 goes on, this is going to be popping on and off. So what's going to happen? We don't necessarily want that. So what we're going to do is we're going to take this C7 because we know this is going to be true one scan, and then we will latch it. Oh, I used to have this in a book. I used to have the page dog-eared because older PLCs, you don't have one-shot logic. So you've got to think, okay, how do I do this for one cycle? But see, this is trying to turn on and off. So when this turns on, this becomes false, turns it off. When this is false, if somebody's still holding the button, it's going to try and come right back on. So you're going to get these little pulses. I'm going to have to look that up. I'm going to have to look that up more. Because you'll get multiple bits. You'll get it oscillating here, depending. And we want X7 to come on and stay on. And then we want to latch that out. So I think that's what we did. We did a set, cancel. So let's do a set C7 there. There we go. So C7 is set, comes on. The minute you push X7, is that right? And then when C7 is on and X7 is off, then you do your reset. Let's see how that works. So when I push X7, C7's off, but it will turn immediately on and it will stay on. And when it stays on, this will stay false. So that's what I got to do. I got to do one more thing. I got to do X7 on and C7 on. I got to do one more thing. X7 and C7. No. This one, C7. And then this would be my output, C8. Okay. So when I push X7, if C7's off, this is true, then C7 comes on. And when C7 comes on, this becomes false, but since we're setting it, it stays on. And so when C7 is on, and until it sees X7 off, it won't reset. It won't turn itself off. So I've got to push the button and release the button. When I push the button, this sets. When I release the button, this resets. Okay, now what I want to do is I want to take this logic and say when X7 is on and C7 is off, which is the same logic that does this line up here, I set C7, then C8 will be on, but C8 will only be on for one scan. And then it will go off because C7 this will become false when C7 gets set. So C8 is my one-shot output. So here's my input in, and here's my one-shot out for an input. So that's what you got to do logic-wise if you don't have it built in. And when you're programming all these one-shot stuff, it's all built in. It's something that somebody has done with just regular logic like this, and they've reduced it down to a simpler way, maybe just one or two things to implement. So I think it's really fun to get down and think, okay, how can I make C8 on for one cycle? And I think this does it. Okay, I digress. How could you create one with standard logic? So there you go. And that would be one shot of an input. And I think you could do the same thing with an output. Let's look at that. If this was an output and you only had it on for one cycle, you could use bits just like that. And then this was an output. Yeah, same thing. So this is an input here. It's an X, but what if it was a Y? Then it would be a one-shotting the output out on C8. And in Allen Bradley, you actually have to select a memory location for the one shot. So, and maybe it's 2, I don't remember. But you're actually selecting memory locations that it's using to store so it can compare and do logic like this. Okay, that is worksheet 22.